So the second part of 1.2, evaluating expressions. This time we're going to actually evaluate some expressions. So we can evaluate expressions if they have all numbers, and if the expressions have all numbers, we're just going to do the math. Whatever it says, we're going to do according to the order of operations. Not much to say about it. But I do want to specifically talk about exponents. So there's an exponential expression. The base is the 5. Often in Algebra 2, that'll be a variable. Exponent, there is 3. We'll also have variables in our exponents later this year. So to evaluate a exponential expression, the base tells us what we're going to multiply, and the exponent tells us how many times we're going to multiply it by itself. So we did 5 3 times. 5 times 5 gave us 25. That would be 5 squared. Right? The second power would be 5 squared. It's a square because it'd be represent the area of a square, right? 5 times 5 would be 25. That would be the area of a square with a side length of 5 units. But this was 5 to the third. It was cubed. So 5 times 5 gave us the square. Then the extra 5 would be a cube, so that would represent the volume of a cube. So just nice to tie those together with something real. One big question that comes up with exponential expressions is, what about the negative sign? So which of these things is not like the other? They all look different, but which ones are different? So this one, we've got inside parentheses that exponent sitting on the shoulder of. We just have a 3, so we're going to do 3 times 3, and then at the end we're going to throw on a negative. So it's going to stay negative 9. This one, inside the parentheses, we have a negative 3, so we're going to square what's inside the parentheses. We have negative 3 times negative 3. We get a positive 9. This time, that exponent's just sitting on the shoulder of the 3. The negative is going to get applied afterwards. So it's like the last one. These two are alike. This one is different. And the reason this throws people off is it's so infrequent that it happens, because if our exponent is different, sometimes it doesn't make a difference. Here's a similar setup, but this time, if I do this one, I'm going to get the same answer. How come this time I got the same answer, yet on the last one I got different answers? Exponent is even. It's really, really important you apply the rules right. Exponent is odd. You can get lucky and get the right answer for the wrong reason. So be careful. The other part in evaluating is evaluating if there's a variable in the expression. Sometimes they'll say evaluate when x equals this, or evaluate if x equals this. If they gave us that, we couldn't do it. Nothing we could do to it. They would have to give us a value for x. So they might say if x equals negative 1. So we would substitute negative 1, do the math, follow the order of operations, and the answer happens to be negative 1. You'll notice the theme today of negative 1. But what if x is 12? Well, we can still evaluate that expression for any value. So if x is 12, we substitute 12 and do the math. We get a different answer. Right? So we could do that all day long, but let's not. Here's a quadratic expression with a square in it. We're going to see lots and lots of these. So we have to make sure we're good at the rules in this situation. So if I plug in a negative 1, I plug it into every x there is. I do substitution for each x. I'm going to follow the order of operations. So I did the exponent before I did the multiplication. Notice the theme of negative 1. Completely coincidental. This is not the correct order of operations, but it's a very common error, so I want to call your attention to it. right? What did this person do wrong? They multiplied before they applied the exponent. And they tend to think, oh, that exponent's on that whole 5x. The exponent's not on the whole 5x. The exponent's only on the x. So don't do that.